Question 6. Question is, prove that the sum of the square of diagonal of a parallelogram is equals to the sum of the square of sides. That means we have to prove that in this parallelogram A, B, C, D, we have to prove that sum of its diagonal AC square plus BD square is equals to AB square plus BC square plus CD square plus AD square. Now, let ABCD is a parallelogram and we have to construct AF which is perpendicular to DC and DE perpendicular to BE. Now, here we have to prove that sum of all the sides, sum of square of all the side is equals to sum of square of its diagonal. Now, for proving this result, first we have to apply Pythagoras theorem on DEA. DEA. For this triangle, Pythagoras theorem is DA square plus DE square plus EA square. Second one is applying Pythagoras theorem on triangle DEB. First of all, we have to apply Pythagoras theorem on DEA and then we have to apply Pythagoras theorem on DEB. For this triangle DEB, Pythagoras theorem is DB square is equals to DE square plus EB square. Instead of EB, we can write EA plus AB whole square. Now simplify this EA plus AB whole square. DB square is equals to DE square plus here A plus B whole square, that means EA square plus AB square plus 2EA into AB. Now simplify this result. Instead of DE square plus EA square, we can write DA square plus remaining part is as it is AB square plus 2EA into AB. Now this is second result. Now remember this result. In next step we will use this result. Now in second part, here we have to prove DB square is equals to this. Now second one, we have apply Pythagoras theorem on triangle ADF, that means triangle ADF. For this triangle, Pythagoras theorem is AD square plus AF square plus DF square. And for second triangle is applying Pythagoras theorem on triangle AFC. That means Pythagoras theorem is AC square is equals to AF square plus FC square. In next step, we have to simplify this result. Instead of FC, we can write DC minus FD, and in the next slide we have to simplify this term DC minus FD whole square using A minus B whole square. Therefore AC square is equals to AD square plus DC square minus 2 DC into FD. AC square is equals to AF square plus DC square plus FD square minus 2 DC into FD. Now here AF square plus DC square, instead of AF square plus DC square, that means AF square plus FD square, we can write here AD square. Instead of these two terms, we can write AD square by Pythagoras theorem. Remaining part is as it is plus 2 DC square minus 2 DC into FD. This is third result. Next one is, we know that ABCD is a parallelogram, and in a parallelogram opposite sides are equal. Therefore, AB is equals to CD and AD is equals to BC. Use this result in earlier results. Now here we have to prove that triangle DEA, that means triangle DEA, the small triangle, and triangle ADF, both are similar triangle. For proving this result, we know that here angle E and angle F both are right angle, and we know that uh, EF and ED both are parallel lines. These two lines are parallel. That means angle EAD and angle ADF both are equal because of these two. These two angles are alternate interior angle, and we know that AD is common side in both the triangle. Then we can say that these two triangles are congruent and by criteria AAS, that means angle side. Now from this congruency we can say that EA is equals to FD. Now using equation 2, as I say, remember that equation, and equation 3, using these two equation we can write here DA square plus AB square plus 2EA into AB plus AD square plus DC square minus 2ED into FD DB square plus AC square. Now here DA square plus AB square as it is, AD square as it is, DC square as it is, 2EA 2AB as it is. Instead of uh, everything is as it is. Now only arranging the order. Here DA, here DA and BC both are equal because of parallelogram. Therefore, instead of DA we can write BC, AB square as it is, AD square as it is, DC square as it is, plus 2EA into AB as it is. Instead of DC, here DC is this. Instead of DC we can write AB here, because in a parallelogram opposite side are equal, and instead of FD we can write EA. Earlier we have proved that is equals to DB square plus AC square. Now both these terms are cancelled, and hence we have to prove sum of square of all the side is equals to sum of square of its diagonal.